Calculate average speed for different cases. So one of the important topics which is there in the NCERT book. So this is very important. Average speed. A number of questions have come in the competitive exam. In all the exams, most of the exam they have asked this question. So let us see how to calculate average speed for various cases. Average speed, will average speed be equal to average velocity? Yes. So average speed will be equal to average velocity when average speed definition is total distance by time and average velocity definition is just displacement by time, because average velocity and velocity both are same. So when distance and displacement are same, then average speed will be equal to average velocity. So whenever a particle moving in a straight line without changing the direction, distance will be equal to displacement, and hence average speed will be equal to average velocity. So sometimes I'll use average speed or sometimes I'll use average velocity. It is understood that both will be same, provided if and only if the body is moving in a straight line without changing the direction. And average velocity or velocity, since both are same, we know velocity or speed definition is distance by time and velocity definition is displacement upon time, or speed is equal to distance by time. I can use both because the body is moving in a straight line, so distance and displacement will be the same. Now here let us see case 1. So here, before introducing case 1, let us see here we have 3 parameters: velocity, distance and time, or speed, distance or displacement and time. When we use average speed, I told you, whenever a speed is varying, for some part of the journey the speed is v1, for some part of the journey speed is v2, and for the remaining part of the journey speed is v3. Like that, if speed is varying for a journey, like if it has a 4 to 5 different speeds, then we will use a average speed. So here in the first case, definitely velocity is changing. Now the remaining 2 parameters are distance and time. So in the first case, what I will do, I will vary distance and I'll keep time constant. In the second case, or in the any case, however we want, we can do it. We can keep time constant and vary the distance, or we can keep distance constant and vary the time, or we can vary all the 3. So case 1, if a body covers a journey, in 2 equal halves of distance, in 2 equal halves means in 2 equal intervals of distance, or I can tell in 2 equal intervals of distance, or 2 equal halves, both are same. It covers a journey in 2 equal halves, or it covers a journey in 2 equal intervals of a distance. Means what? Let us say a body is moving from point A to point B. So it is covering this journey into 2 equal intervals of distance, or 2 equal halves. Means, so if I take the distance as d, then this distance will be d by 2, and this distance is also d by 2. So to avoid fraction, what I will do, I'll take the complete distance as 2d. So this will be d, this will also be d, because it is telling that a body is covering a journey in 2 equal halves, or 2 equal intervals of distance, with speeds v1 and v2, with speeds or velocities v1 and then v2. In this case, I have to calculate what is the average velocity. So he is telling that a journey is divided into 2 equal halves. First part of the journey, it is traveling with the speed v1, and the remaining part of the journey, the second half of the journey, is traveling with the speed v2. I have to calculate what is the average speed for this. Now will time be same? Now we know velocity equal to displacement by time. So this implies that distance is equal to velocity multiplied by time. So distance is same, this is same, but velocity are different. So from this, what do we get time as? So if I calculate directly time from this, time is equal to distance by velocity. So distance is same, no doubt, distance is same, but for the 2 journeys, velocity is different. If v is different, obviously time will also be different. So therefore time will be equal to t1 and t2. So like what I told here, in the first case what I have kept constant, I have kept a d constant. That means it is covering the journey into 2 equal halves. We can divide it into 3 equal halves also and we can understand, but the simplest case what is mentioned in the NCERT book is for 2 cases. That's why we have taken 2 cases, and then we can generalize for 3 intervals, 4 intervals of distance, 5 equal intervals of distance, and up to n equal intervals of distance we can generalize the result. So here what I have done, I have divided the journey into 2 equal halves. That means distance is d and d, and this first part of the d is covered with the v1 and the second part of the distance is covered with the speed v2. Obviously time will be different, so time t1 will be here t1 and here time t will be equal to t2. So I have kept a d constant. I have kept a d constant. First parameter I have kept constant. V and t are varying. V is obviously varying because average velocity means velocity should vary. So out of these two, in the first part I have kept a d constant and time varying. So let us see, calculate what is the average velocity here. Average velocity or average speed, both are same here because the body is moving in a straight line without changing the direction. So average speed definition I'll write total distance divided by total time. The basic definition, the total distance divided by total time is the definition of average speed. If I write average velocity, then it will be displacement by time. Displacement is same as distance here. Total distance, how much is the total distance from A to B? The total distance is d plus d, or you can take d by 2 also, still you will get the same result. Total time will not be same, so it will be t1 plus t2. So d plus d will be 2d divided by time. Now I have to write the equation in terms of v1 and v2. v1 and v2 will be given in the problem, so I have to write the result in terms of v1 and v2 only. So time, what I will do, time I'll write in terms of distance and velocity, so that distance can be cancelled and velocity will be remaining. So the basic definition is velocity equal to displacement by time. So time will be equal to, from this, distance by velocity. So the first interval distance is d by velocity, that is v1, plus for the second interval time is t2 and distance is still d divided by v2. So what I can do here is I can take out d common. I can take out d common here. So average speed will be equal to 2d divided by d. If I take common, the remainder is 1 over v1 plus 1 over v2. So d and d will cancel out. So I'll get 2 by 1 by v1 plus 1 by v2. This if I rearrange so that I can generalize it for even n equal intervals of distance. V average I'll take it this side, and this part, this complete part, if I shift this side, so I'll get 2 by this v average will come down. So 2 by v average is equal to this 1 by v1 plus 1 by v2 will go this side, and this v average is coming down. So that will be equal to 1 by v1 plus 1 by v2. So from this we can easily calculate the v average result, whatever is v average. So let us simplify here. So let us simplify this here. I wanted the standard result, that's why I've shifted this part here and this part there. So 2 divided by LCM, if I take, it will be v1 v2 and then v1 plus v2 or v2 plus v1. So v1 plus v2 upon v1 into v2. So this will come up and it will reciprocate. So from this I'll get the value of v average.